This is on page 8. So in general, the absolute value parent function means the most basic parent function. So yesterday when we were graphing on decimals, at the top, what we did is we put in just this equation. Correct? Okay, so this equation, the parent function, if you want to think about it, let's put in some values. What's the absolute value of 0? 0. If I put positive 1 in, what's the absolute value of 1? No, what's the absolute value of 1? 1. If I put 2 in, what's the absolute value of 2? 2. Okay, so the right part of it looked like this. These are going to be two lines. This has a slope of 1. Okay. What if I put negative 1 in? What's the absolute value of negative 1? 1. The absolute value of negative 2 is 2. Okay, so then the other part of it forms a V. It's made by two lines. Okay, and the slope of the right side is 1. The slope of the left side would be negative 1. Does that make sense? Okay. So what we did yesterday is we started to add some things to the equation, and we're going to summarize what all of those things do right now. Okay. So first of all, the first thing I had you do is I had you add something at the end. That was what we did in this first section right here. Okay. What did that do to the graph? Moved it which way? Up. Or down. Okay, so what we're going to do here is we're going to draw an arrow. That plus K is going to move the graph up or down. And it's kind of like what you would think. When it's addition, it moves it up. When it was subtraction, it moved it down. Then the next section, if you went back, okay, the next section, should be writing this down. This next section, I didn't see anything written on your paper. Just own your mistake, please. Just own your mistake. We all make mistakes. You just got to own them. This did what? Inside. It moved it to the left and right, but we have to be a little careful with this one. So this moves left and right. But when it was actually a plus sign, I'm going to put a little plus above here, it moved it to the left. Remember how it was the opposite of what we thought, just inside. And then when it was a subtraction, it moved it to the right. All right, how about if I put a number in front? It changed the slope, didn't it? Okay, so it changes the slope. And we are calling these transformations, meaning if the slope is changing, didn't it make the slope either steeper or less steep? Okay, we call this a vertical stretch. Think of stretching something. If I stretched that V, would it make the slope steeper? Yeah, so it's a stretch if it makes it steeper, but if I go like this, I call that a shrink. I'm compressing it. It would make the slope less steep. How do I tell? Okay, you tell me, if A were a 2, do you think it would be a vertical stretch or a shrink? Stretch. If A were 5. If A were 1/2. Shrink. Okay, so if A is a number bigger than 1, think about multiplying by something bigger than 1, okay? Then it would make the slope bigger than 1. And if it was something between 0 and 1, like a fraction, then it would make it a shrink. So that's how we tell with that. There was one other thing that happened, and I didn't put it on here. If there is a negative in front, There's a negative in front. What that did is it reflected over the x-axis. All right, so then we went on to these examples yesterday, right? So you already have these written down, but I'm going to quick put them on the graph. So this moved the V3, oh, no, it didn't. This moved it 3 down, so you had your absolute value graph, and it had a vertex. This point right here is called the vertex. The vertex was what coordinates? 0, -3. Notice my slopes of my line are 1 and -1 because I didn't change the slope. All right, then what happened with this one? It moved from 0, 0 to what? What do you have on your graph? Okay, -2.5. It moved to the left 2.5. So and I'm still making my slopes 1 and -1. This would be -2.50. And then these ones, these were vertical stretches, okay? So they changed the slopes to up 3/1 and -3. Okay, so that's this graph. But then when I throw a negative in front, that just flipped it upside down, didn't it? Okay. All right, good. Let's move on then. How about if I tell you what it does, let's write equations, okay? If I wanted to take the absolute value of x and move it 9 units down, can somebody tell me what the equation would look like then? And I close it, right? And then -9. What if I wanted to move this absolute value of x 10 units to the left? X plus 10, but it would be inside the absolute value bracket. Good. All right, what if I said 2 of them? Let's put them together. All right, what would go inside, okay, and what would go outside? The 5 would go inside, and it's 5 to the right. Remember, it's x is a liar. I told you that yesterday, so it's x minus 5. 3 units up is plus 3. Okay. Describe how the graph of y equals absolute value of x and absolute value of x plus 1 are the same and how they are different. Okay, and I want you to think about the graphs. All right. There are a lot of similarities. I'll start us off. They both open or point up, don't they? What are the slopes of both of them? Be more specific. They both have a slope of, I'll write plus or minus 1 because one part of the V is positive 1 and one is negative 1 because there's nothing in front that changes that slope. Okay. They're both absolute values, right? So you can say both V-shaped. All right. What's their difference? Think of their vertex point. Do they have the same vertex point? No. Absolute value of x has a vertex of 0, 0, because remember absolute value of x is this graph. What would the absolute value of x plus 1 have a vertex of? What do you think? Give me a coordinate. What one? 1, 0 or 0, 1? 0, 1. Okay. Good. So, now let's talk about your homework. I asked you to do the top 3. And here's the deal. Many of these questions on the top 3, it's just asking. So if it didn't happen, your answer is no. Was number 1 reflected over the x-axis? No. Was there a vertical stretch or shrink? No. How would I tell that? Is there a number in front? Nope. Okay. Did it move left or right? How far? Yes. Which way? Right. 2. Did it move up or down? Is there anything over here? No. Okay, what would the vertex be then if it moved right 2? Instead of 0, 0, it would be 2, 0. Number 2, is this reflected over the x-axis? No. Does this have a vertical stretch or shrink? That would mean the slope changes. No. Does this move right or left? No. Did this move up or down? Yes. Which one? Up 3. So what's the vertex? 0, 3. All right. Is this reflected over the x-axis? No. Let's pause a second. Look on the page for one that would be reflected over the x-axis, just so we... 6. How can you tell? That negative in front. Okay. All right. Let's go back. Is there a vertical stretch or shrink? No. There's no number multiplied in the front. Is this moved right or left? Left. How far? 1. Is this moved up or down? No. Okay, so if it moved left 1, what would the vertex be? Negative 1, 0. Okay, so those were the answers that you should have gotten for the homework.